Hello students, this is Dr. Diaz and I'm here today to talk a little bit about SN1 versus E1. Yesterday night I received an email from students that asked me about how we're going to determine if it's SN1 and E1. I'm struggling on this. So I'm here to help you with some hints over here. So SN1 and E1, they are always compete with themselves, with each other. So they both have a stepwise mechanism. That means we both gonna have carbocation. This is why I put it up here, the positive sign. But when we have tertiary carbon, tertiary carbon, so we have some substitutes over here, and then we have the halide over here. So generally, will be favor E1 will be favor over SN1 if heat, it is why I use the triangle over here like a hat, heat is applied. Okay, and second thing to remember is the elimination reaction of alcohols is possible when acid is added. And we use this as an example to give you more hints, okay? So, the both are unimolecular. So we have both have a stepwise mechanism. So we have a carbocation intermediator. With lower temperature, we have SN1. Higher temperature will favor U1, okay? So when you have nucleophiles like chlorine, bromine, and iodine, SN1 will dominate generally. Okay, when you have weak nucleophiles, so there's or non-nucleophiles, weak non-nucleophiles, so it will be more base than nucleophiles over here. So we have HSO4, for example, TSO4, no, TSO4. I'm going behind the HSO4. So minus, and could be H2PO4, so on. So E1 will dominate. That is a good hint. So, but let's grab an example, the one that I use during class. So imagine if I have this over here. So I have OH over here, which is a bad leaving group. Remember, bad leaving group. And we can add an acid. And we gonna see the hydroxyl here working as a nucleophile and extract this hydrogen over here. And I'm gonna have this, the water molecule over here, but now with a positive sign over here, which is a good leaving group. And then you're gonna say like, okay, so now what is E1 or SN1? So pay attention to this. If I'm gonna, so this will leave, right? Because it's a good leaving group. So now I'm gonna have this, a positive charge over here, right? These are gonna have. So imagine if I have, and this acid over here, let's highlight this, the S. because this is an acid, HA, it's an example of acid, okay? It's just to exemplify. So, but A can be chlorine, chloride, bromide, iodide, for example. So if this happen, so I know that SN1 will dominate, okay? And what you're gonna see is this over here, right? So we're gonna have chlorine over here, or bromine. Oh, I'm sorry, this is, let me just organize this. So I have chlorine, I could have bromine or iodine over there. So, but if I have, here's my positive charge, this A over here is not chlorine, chloride or bromide or iodine, but instead we have SO4 minus, TSO minus, or A2PO4 minus, all those. So in this case, E1 will dominate, okay? And here you're gonna have, you know how it works, right? So this will attack the hydrogens on a beta carbon, as I said. So beta carbon is the carbons, here, let me change this color, not get confused. So here it's a beta carbon, here is a beta carbon, this beta carbon is a carbon that is neighbor of the alpha carbon. So this is beta, beta, and beta, and this is alpha, is the neighbor. So when this catch the hydrogen that is over here, we're gonna have a double bond over here, because this hydrogen will leave behind the electrons, forming this double bond over here. And we're gonna have elimination. Okay, of course, could we have this over here, remember, and here. So, and we have Zaitsev, Hoffman over here. And recall who is our major here. Remember about what I said about E1, it's always Zaitsev. That will be the major, right? E2, we can have Hoffman as the major. So that's it. That's all.